All right, so I think I'm going to go ahead and start. Again, as long as you have the bit.ly link for this page, this has all the instructions. So this is the entry point. I'll leave this up for a little bit longer. Just to give a summary of what I was going to cover today, Andre covered basically open source MLflow, what you can do on your laptop using MLflow. What I'm going to cover is managed MLflow. So if I don't want to start up my own tracking server on my laptop, or I want something persistent that lives on blob storage, S3, or Azure Blob Storage, then I want some managed service or capability to be able to do all that for me. So if you don't have a persistent tracking server, you need to set up a separate EC2 server in Amazon if you're using AWS. And you need to basically just keep track of your artifact store and maintain those things separately. So the whole point of managed MLflow is I want my all of my experiments managed for me, and I want to be able to very tightly integrate that with my code as well, so my notebooks. So I'm actually going to use a Databricks Workspace to kind of demonstrate a bunch of these concepts today. And what you all have, this is the same workspace that you're logged into now. If you actually go into, as I said before, this shared folder in the workspace, this kind of has all the different artifacts that we're actually going to be going through today. So in this final SAIS 2019, you just click in that folder and click any particular notebook. So you can just start with notebook 1A, for example. This is actually going to go through or show you a couple of different ways of defining an experiment. So Andre went through the APIs to do this on your laptop. This is a little bit more visual and interactive, so that's kind of the point of having this very tightly integrated within this Databricks Workspace, for example. Before I can execute any of these, you're going to want to create a cluster. I actually set a template cluster, so please follow this example. This template cluster has a runtime version of 5.3 ML. That means it's got like TensorFlow, Keras, a bunch of deep learning libraries, and scikit-learn already installed. We will be making use of that if we get to like the more advanced notebook or demonstration. But the core part is just make sure you have a small worker. An i3x large machine or something smaller should work. And you don't need more than one worker. We're not going to run anything very intensive today. The data size isn't going to be something that necessitates more than that. So feel free to spin up, like I said, a really small cluster, no more than one node. And you should be using Spot for your particular cluster. So this looks good so far. And again, just make sure you're not auto-scaled. You're just basically using a node or somewhere around that. So I'll give this a minute. This typically takes a few minutes, but with a lot spinning up, it may take a little bit longer. What I wanted to really cover today is kind of what MLflow looks like if you're using a Databricks Workspace, but more generally what the managed component is. So from this first example, there's a couple of different ways you can create an experiment. There's this concept of a named experiment. So if I call my experiment, or I specify the folder, this is kind of like just a file system folder structure, and then I call it something specific, you can actually change this experiment name to something that's particular to your user. So whatever your user happens to be, you can kind of specify that as a subfolder and save it wherever you want. But as I run through this, you can go back to this folder in the workspace and find, here I just specified shared and default experiment. So when I click into that little beaker, it's going to take me into what I just defined. In this case, it looks like I've run this experiment. It keeps a timestamp of every time I run it within the UI, very similar to the open source version. But for example, something that you're going to notice is a little bit different is you're going to get a link back to the source code. So this is kind of what the integration is all about in the workspace. And not only do I get a link back to the source code here, it's actually going to take me back to a very specific revision of that notebook. So I actually ran this a couple days ago, so it's taking me back to that revision, and I can restore that revision or understand exactly what I called MLflow from. So if I go back, I'm actually going to go back to this experiment. Other things of note, like I said, things like the artifact store, where your models are ending up. So artifact location here, you're going to notice is, again, managed for you. So I don't have to think about what root bucket or S3 bucket or blob store I'm actually storing all of my artifacts in. All I have to worry about is this is an experiment I'm defining. I want to save it. I want to load it. And just having a relative path to worry about. So that's the other aspect. And Andre covered a little bit of this, but from the UI, you can kind of look at condensed views, more expanded views. This makes a little bit more sense when these parameters that you're logging or metrics that you happen to be logging are nested, so maybe like a JSON blob or something like that. But you kind of have different options here, and if you want to download all, like the history of all experiments, you can do that as well from the download CSV. So that's a little bit about the shared experiment. And I'll just go back to this latest version. So it looks like a lot of clusters are up. How many people have been able to at least run this first just named experiment? All right, perfect. So this is just a really basic example. The other example of running, if you go to this 1B, one thing I forgot to mention. If you are using this code, you can clone this folder in your own user folder. So you should see an option to do that. For example, I am the MLflow user here. If you clone it in this folder, it'll make a copy here so that you don't necessarily change the root folder. All right, awesome. So like I was saying, this is the second way of defining an experiment. So in this case, I'm just calling the APIs. And instead of like specifying the named experiment, this is all creating the run inline. And what you're going to see now is actually this runs in the top right corner. This is a little bit small, so let me blow it up. The runs in the top right corner are actually going to display all the specific runs for this experiment. So again, it's just kind of like not having to navigate back and forth from the named experiment. If you don't want to like store it separately, you can just view everything from here. And when you're ready to kind of collapse it, like you would for comments, for example, you would just collapse it and then just keep coding. So this will create an experiment just on the fly and maybe a little bit more convenient. So here, actually, we're opening up this experiment. We're actually printing off all of this information, but this is all retained within the experiment itself, too. So things like the run ID, experiment ID, even the run URI, things like that. If I use this, I can go directly to that specific run if I want to do that via link. So I'll just go through that here. So as you can see, it just took me back to something like the named experiment before. If I happen to be running this, Andre kind of covered what you can do as far as running an experiment off of a project in Git or GitHub. So if I did run something off of GitHub from my laptop, for example, if I ran it here, it'll actually record the Git revision or the Git hash that you're actually using. So if I run this experiment and I look at the Git hash, I can go back 6 months later and understand exactly what code I ran against. So there's a lot of stuff that's recorded here. It's very convenient. Like I said, if you're not having to manage all these artifacts, stores, and all this stuff by yourself, it's very powerful. So you can just focus on experimentation here. All right. So let me just go back here. So the second experiment should be very similar to the first. I'm actually going to move on to some of the actual model training. So the way that I've set this up, and remember to make sure you clone this folder, so you're not necessarily running concurrent runs of the notebook, which will probably lead to failure. There's a few parts to this, so I'm not expecting we get through all of these notebooks. If you happen to be going a little bit faster, and you just kind of want to go through on your own, this is a broad sketch. So I've kind of numbered these notebooks. The 2 notebook is the sklearn version that Andre went through. This is the managed version, so it'll just do model training. At the end of that notebook, you'll see a run ID or run ID hash for your experiment. And for example, when I look at the predict notebook, you can just pop that run ID back in here, and it'll just do all the inference based on that specific run, that model run. So that's the way all these generally work. If you're more comfortable with Python, you can run these Python and Scala versions. Oh, and one thing I forgot to mention from the README, once you start running the sklearn and the Python and Scala versions. If you want to run through the MLeap specific parts, you're going to need a couple of libraries. So where are these libraries? Here we go. I'm going to leave this up for a bit. Hopefully you should have the link to this doc. This is the first doc that I went through. You need a few packages. So there's 3. There's the MLflow client. And again, this is, I think, mainly if you want to just look at MLeap and all the Scala stuff. So you install this from Maven, and there's instructions in this document on how to do that as well. So the PyPy package stuff you're going to need is MLflow. You want MLflow attached to your cluster so that you can actually execute those commands. And then the last thing is MLeap. So there's a conversion to an MLeap flavor for some of this code. So you're going to want to install this via Maven too. And I'm just going to do like a really quick run through of what that looks like here. So if you want to install, I'm going to import a library. So there's one from PyPy that was just MLflow. If you want to install that, I'm going to install like an old version. You would create it here, and then you can attach it to your specific cluster, whatever that happens to be. That's the PyPy installation. If you want to do Maven, it's very similar. So here I have MLeap. If you want to install Maven, I just click on Maven, make sure that you provide it in the coordinates, and then you would just create that similarly, and then basically attach it to whatever cluster you have. If you're not interested in like the MLeap versions or saving in that specific format, you don't have to worry about MLeap. If you just want to focus on Python and some of the Python inference, you can just stop short of using any of the MLeap capabilities. But this is how it works for all those. So let me go back to the overview here. So yeah, try to install those libraries now. It'll take maybe a minute or so to have that installed. But after that's installed, you should be able to run through all these different notebooks. So the sklearn, again, will just train and predict based on the run IDs. The Python and Scala are more specific to Spark. So it'll create train a PySpark model or train a Scala Spark model. And then there's kind of a fun one at the very end. This one is actually bike share data. So this is, the UCI has a public data set. Kaggle actually has their own version of this. If you've ever kind of done some of the projects or, I guess, learning data sets on Kaggle. So what it's trying to do is just a regression problem, trying to predict the number of rentals per specific date time or per hour. So this notebook is actually just downloading that data, the public data, and it's actually walking through, this is just the download stuff, but in addition to kind of showing off some of the visualizations, near the end, it's actually training multiple TensorFlow models in parallel. So one of the really cool things about using MLflow is that in addition to tracking kind of like different experiment runs with parameter tweaks, in a lot of cases, it's really powerful to be able to do a very large hyperparameter search. So if you're doing that in PySpark, if you're doing it using sklearn, it doesn't really matter. In this case, we're just running a bunch of TensorFlow models based on number of layers, for example, but you can add as many things as you want to the grid. And what you can do is actually, so here's my parameter grid. You can kind of see there's layer size, number of layers, activation, like L2 regularization. I just made these very small, so actually it's just going to run 4 experiments in parallel. But you can imagine scaling this up to something like hundreds of different experiments, and typically a grid is going to be fairly large for different problems. So you can actually use Spark to parallelize all this work. So in line 51, for example, this map partitions is telling me on each partition, I actually want to train a different model. So you can really run as many models as you have tasks or cores for your specific cluster. So if I have 100 cores on my cluster, I can train that many models in parallel, move on to the next batch, and then go through a search that maybe 1,500 parameters or so. Not only that, if you actually look at what this what this train model is returning, it's returning my model, it's returning my parameters, my specific evaluation for this TensorFlow model. And that actually allows me to, in a subsequent step, you can see here, all I'm doing is looping over all of my evaluations, my parameters, my models, and I'm actually recording every single thing in MLflow. So I don't have to worry about creating a spreadsheet with all these different runs, recording what I did, what data I ran it, what the best parameter was. I'm logging all this stuff here. I'm even going to log the model, so this will take a little bit of time when I log this model, but it'll persist all of this stuff to MLflow, to my artifact store. So I'm going to just take a quick look here to show you what this looks like. So there's a bunch of experiments here. You can put these in your own folder, shared folder, doesn't matter. This is the actual experiment that's tied to that notebook that I just reviewed. So yeah, just to give you an idea, this format is a little bit hard to read. So I'm actually going to expand it out. So as you could see before, some of my parameters were a little bit squeezed in here. So it's kind of in a vertical format. I want to list it like this, so I can kind of see everything in a more tabular way. It's obviously recording the user here, the exact source code from my notebook, and the date as well. And what I can do here, you can see this particular user had 4 different runs logged. If I highlight all these, I can compare. I think Andre showed a little bit of this functionality before, but you can kind of see this tabular view of all the different hyperparameters that you tested with. So that's valuable. So things like number of layers are changing, or maybe the regularization parameter, as you can see here in this row. You can see the metrics here that I wanted to record with, but if I specify something like, let's do regularization, and whatever my metric happens to be, you can see all these points are just distributed here, so you can kind of have a more visual representation of what went well, what didn't. So it's recording the run ID and what all those different parameters were for that specific run. And I think one thing that we have in MLflow that's a nice, construct is the notion of a nested run also. So in this case, I just logged 4 runs almost independently within this particular experiment. But if I go back, I'm going to go back to the code here. If you actually happen to start a parent run here, so I can kind of nest a parent run, and as long as I just nest the code, so do a start run within another start run, it will actually create an outer layer or an outer run, and then track all of the child runs, so all the hyperparameter runs within that experiment as well. So you have that flexibility in case you don't want to see kind of 4 stray experiments. But this is a really cool, I think, way to just view like a hyperparameter tuning search basically within the MLflow UI. And one thing that's actually on the roadmap is to incorporate MLlib and MLflow. So if you're using Spark MLlib for really big data model training, and you do something like a grid search or like a cross-validator, then you'll be able to see things like the parameters for the grid integrated within MLflow, so that's just a little bit more seamless. So right now you can see this is a little bit manual, right? I had to track everything on my own, basically after the fact, after training everything. So we're going to have a lot tighter integration for stuff like this, and integrate things like hyperop too that make parameter searches a lot more intuitive within the MLflow UI. Are there any questions so far? I'll take a breather here. Yes? Yeah, is the question how it performs with a large number of hyperparameters? How convenient is it to use in your own environment?
For example, if I want to see only my experiments.
Mm-hmm. Yeah, so actually I think this is already available. I don't have this demoed here, but we have the concept of like an experiment, like access control lists and things like that to block off access for other users, who you don't want to see your particular experiments. I don't know if you can put this in the filter. Is that possible?
Standard Databricks object function. Experiments just like any other function to prevent
Yeah, actually, let me show that. I can just show it within the actual workspace. So if I click on a particular experiment, I can actually restrict who can see it. It's very similar to just like the typical RBAC for like a notebook or something like that. Yeah. So you can restrict those permissions, but then, and then do querying on this as well. Any other questions? Yeah, let me actually go into, I kind of shot to the end a little bit just to show where we were going. So like I said, once you have those libraries for your cluster attached, feel free to go through this at your own pace. I'm actually going to jump into this sklearn to kind of demonstrate some of the model deployment and how it would work for the different flavors. So this particular notebook is grabbing some of these parameters from the widget values. It's getting alpha and L1. This is the wine quality data set. This is actually just in our quick start. But I'm going to show a little bit. Andre covered a tiny bit of this, but it's kind of just showing the UDF construct. So after I've set my experiment name, all this stuff that I've done before, I'm just downloading my data here. And there's nothing particularly special. This is just training methods into which I'd inject all my different MLflow calls. So log metric, things like that, adding plots. So at the end of this, basically, I get my run that I can look at, my nice link here, as well as my run ID. So I'm going to grab this. So if I pop into this predict, so this is kind of like the whole concept of the flavor, right? For the flavor, if you're using sklearn, you can think of it as just a Python function and basically convert it to a UDF in this way. But this really would work for all the different flows. So PyTorch or TensorFlow or whatever you happen to be using. So the way that you would call it is just MLflow.tensorflow or .sklearn, and then you would just say save, and that saves the model, or sorry, log model. That would log it in a managed context. And then based on the run ID, so you can see here, let me go to the load. Yeah, so this MLflow.pyfunc here, it called this Spark UDF, but I could have easily just as called like a load model, basically. So I would just specify the flavor, so sklearn.load model. In this case, I'm actually using UDF. But you would just specify like the relative path and the run ID. And this is all you need to actually deploy the model as well. So if I were to deploy this to like Azure ML or SageMaker, I would just say MLflow, MLflow.SageMaker, and then deploy. And I just specify the exact same thing. So model, path, run ID, and then we know how to basically send it with a container to SageMaker, for example.
So, you have your model, the model is track and flow. And then you deploy it, let's say, like this in SageMaker. Is there a way to understand or to update the tracking, to understand the stage in which the model is? Let's say you have a pattern, so you deploy the model first in the stage, and then you go to production. That's the life cycle. And then the model eventually decay will put that model offsite to start again all the pattern. So my question is there a way to track all that elements in the tracking part of that?
Yeah, that's a good question. I'm not sure if, is tagging relevant for some of this? Andre, have you played with that?
You mean you want to track prediction score? No, the life cycle, the status of the life cycle of the model. So for instance, I have the model. I deploy it in my compiling it from the state with SageMaker. That model is in this model state.
great feedback. Yeah. All right. So yeah, so I kind of actually walked through the sklearn stuff here, just demonstrating some of the flavor. So I'm just going to go through a little bit more, and then I'll open it up to more questions if there's anything specific. For this one, as Andre said, you can create the Spark UDF out of any of these models. And there's this cool, succinct way to do this in the data frame API where you don't have to actually specify all the columns you're using. So you just score on all these columns that you use for your model, using the DF columns, the star DF columns there. And you get your predictions. And the nice thing about this is if you have multiple models, you could just load them with different run IDs that you happen to be using, and then just add each different prediction, right? You can kind of add them as different features almost if you were going to feed them to something else if you had slightly different models. So that's a really nice feature, especially if you're interacting with analysts who aren't going to know how to load a TensorFlow model up and actually score records or do inference. You can actually expose this even in something like Spark SQL, for example. So right now it's just a UDF, but you could register this to actually use it in a little bit more of a friendly way, like a business analyst friendly way. So that's a little bit about the UDF. And like I was saying before, this is that model flavor load that you're going to get. So this is kind of like the managed loading of the model off of the artifact store. Again, I'm just specifying the relative path that you define for your model as well as the run ID. And in this case, it's great. I'm actually not scoring. I may not have a need to score on lots of records. I'm just going to score on my pandas UDF. So in this case, I just convert my data to actually a pandas format, and then I'm predicting on the pandas format, and then taking a look at that data with the concatenated predictions and then the actual data that I'm scoring on. Okay. So yeah, there's something new here. The additional stuff there were some additional notebooks here that were a little bit more Spark specific. So I think these were more aimed at, again, using the Spark MLlib package. But the constructs are mostly the same. They just use a different model. So this just uses a decision tree, but it's going to be mostly agnostic in this context. One thing I did want to mention, if there's a particular flavor that's not implemented or that you need to use, it's actually fairly easy to implement your own. So if you look in MLflow documentation, obviously here I'm using the Spark flavor. If you happen to be using XGBoost or you're using a spacey model, you can define those formats. I think in our public docs, we have an XGBoost example of how you would define your own model flavors, and we have a blog coming out soon to kind of talk a little bit more about that. But we've worked with various customers on doing things like spacey that are NLP specific, for example. So it's typically maybe, I think, 50 lines of code just to define your flavor, just to define how to basically log and load a model. It's just telling you how to load up a spacey model. And then you can actually use the same MLflow APIs and kind of customize your flavor. So that's another option. OK, so yeah, as I said, this is more, again, it's just a decision tree classifier. But it's going through the whole pipeline. And again, it's not, the nice thing about this for Spark in particular, if you're doing kind of a batch inference or batch predictions, you're not having to track these different S3 paths on your own and figure out like which run went to production, which didn't, what's kind of working right now, or even how to compare those different runs. This is all managed for me, so I'm just having to think about, hey, here are my run IDs, they're all displayed. I can filter on the best metrics, and then go from there. OK. So just going to go through the Scala version a little bit. This is basically same as decision tree as before, but more focused on the Scala API. So if you're more comfortable here, this is the notebook for you. So this actually uses the MLflow client from Maven that we actually downloaded before. So this is where that's coming into play, getting things like the experiment ID with these like Scala or Java native methods. Yeah. So as I said before, there's something called the mleap utils. So the mleap flavor allows you to save something like a Spark model, but then pick it back up in something like Java, where you may not want to have the overhead of Spark when you're actually doing kind of like a closer to real-time inference. So we have some documentation on how to do that, like how the Java code would look like once you save the model in MLeap format. So this just gets you there faster. So with the flavor construct, basically I just say, model or MLflow to mleap.save, and then you can load the model up and use it that way. But this should look familiar for more Scala-centric folks. We have looks like about 4 minutes left. If you guys have any questions, we can open it up for questions and see if there were any issues with notebooks. Yeah. Oh. Sorry?
User logins which you have given, how long that's valid, like we can use it.
Sorry, can you put it a little bit closer?
So you have given us the credentials, user credentials.
What about the credentials?
Yeah, so how long that's valid? How long can we use these notebooks and these models?
So all the code here in the workspace, as long as you can load them in. Did you want to see the credentials, this thing again, or any of the documents?
Yeah, I have that. I'm just asking how long can we use it? Yeah. So how long can we use it, these credentials?
We'll probably cut it off like at the end of today's, near the end of today's session.
Okay.
But what you can do is actually, if you go into this folder, I think you can download the whole folder. So you can actually export this as this DBC archive or as HTML file. And if you save it in this HTML, it's just a big zip file basically. And you can load it back up. You can load it into Databricks, or you can actually save off the HTML, and you can see the code there, so you can use it later. Yeah, so feel free to take the notebooks and then look at the source code, reuse it. Yeah, I think everybody had the login information, so use it. But we'll cut off access to the workspace at least at the end of today.
Hi. One thing is unclear for me, actually, is how to track data versions, because we are tracking the number of parameters. We can do it easily, but if the data is changed, then our reusability is also in the question mark. I mean, what is the best practice in this area in data tracking version chain?
Yeah, that's a great question. So what we do recommend is things like tracking your specific, whatever data that you used. If you can't log the data itself, at least log the path that you're consuming from, if you happen to be consuming from raw S3 paths for your data. But the other thing you can do is, this is kind of it's part of the integration with something like Delta. If you can record the version of the data set for your particular experiment, you can actually always go back and query a specific version. So that kind of goes back to just using a format, a version format of data generally. But in a lot of cases, organizations do have a specific version tied to the data that they're reading. So logging things like the version will help you track exactly what data you read. And then on the kind of the model changing on new versions of data too, I think that goes back to something like understanding model drift or model registry. So that's a separate component which we're going to tackle next for MLflow. Any other questions? All right.
All right.
Thank you, guys.
Yeah, if there are no more questions, maybe we can give our speaker another round of applause.